So it looks like Mark Zuckerberg has struck again.
He certainly has.
The big news dominating every headline is that Meta is buying the Singapore-based startup Manus for a stunning $2 billion.
Yeah.
And what's so instructive here is just the sheer velocity. I mean, the company only launched this spring, went viral almost instantly with a really slick demo, and now a $2 billion exit.
And that speed is really the core of what we want to dig into for you. We're going to frame this whole thing around, say, 3 key areas.
Okay.
First, just that unbelievable financial velocity. Second, the deep strategic need this fills for Meta. And third, the significant geopolitical wrinkle raised by the company's origins.
All right, let's start with that speed element. The thing that made Manus the talk of Silicon Valley was that demo video, right?
That's what kicked it all off.
Their AI wasn't just another chatbot. It was shown doing these really high-level tasks like screening job candidates for cultural fit or, planning these complex multi-stop vacations and even analyzing stock portfolios. They were ambitious. They actually claimed it outperformed some of OpenAI's own research models.
And that buzz, it translated directly into some, well, frankly, jaw-dropping numbers. Just weeks after launching, Benchmark led a $75 million funding round.
Benchmark, the big VC firm.
The one and only. And that round immediately valued Manus at $500 million post-money.
Wow.
And even before that, they'd raised $10 million from huge names: Tencent, Zenfund, and HSG, which you might know as the former Sequoia China.
But it wasn't just hype. I think the real turning point was that they proved pretty quickly they weren't just a research lab. They were a business.
A real business.
Yeah, despite some really aggressive pricing, you had to pay like $39 or even $199 a month. Manus just announced they have millions of users.
And crucially, they crossed $100 million in annual recurring revenue.
ARR. And that ARR is the key metric, isn't it?
It's everything. For anyone unfamiliar, that's the gold standard. It's what separates a real functioning subscription business from just an experimental AI project.
Wait, hold on. So you're saying Meta, a company that's spending $60 billion on its own AI infrastructure, needed to spend $2 billion on an 8-month-old company just to get some revenue proof?
That's a great question.
Couldn't they just build that themselves?
It's the cost of speed and, validation. They paid exactly the valuation Manus was looking for in its next funding round. For Zuckerberg, who has staked Meta's entire future on AI, this deal just calms all that investor twitchiness.
The twitchiness over the $60 billion not yet making money.
Exactly. Manus is immediate proof of concept. It's product validation that works right now.
So this is less about an acqui-hire and more about buying a finished product that is demonstrably profitable.
Precisely. And the plan is to keep Manus running mostly independently, but also to start weaving its AI agents directly into Facebook, Instagram, and WhatsApp.
Right alongside the existing Meta AI chatbot.
But that strategic payoff, it wasn't so simple. It actually came tangled up with a really uncomfortable political issue.
Okay, so this brings us to that geopolitical wrinkle.
Yeah. So Manus launched just 8 months ago, but its founders are Chinese, and they first established the parent company, Butterfly Effect, in Beijing back in 2022.
Before moving to Singapore more recently.
They officially moved the holding company to Singapore in mid-2025, yeah.
And that history got attention almost immediately. Bipartisan scrutiny. Senator John Cornyn, a Republican from Texas, even called out Benchmark on X.
What did he say?
He accused them of subsidizing our biggest adversary in AI and suggested the tech could be used to challenge the U.S. economically and militarily. It just shows how sensitive this all is in Washington right now.
Think about that for a second. An immediate $2 billion deal, and the first requirement is a surgical removal of every single Chinese tie.
A total cleanup.
A total cleanup. Meta told Nikkei Asia that after the deal, Manus will have no continuing ties to any Chinese investors, and specifically, it will shut down all of its services and operations in China.
So they're just cutting the cord completely.
Immediately. It's a non-negotiable cost of doing business at this level.
So let's just recap for you. What we've seen here is a $2 billion AI acquisition. It was driven by Meta's strategic need for a proven, revenue-generating product, but it was also complicated by these geopolitical concerns, which Meta handled by just cutting all ties to China.
Right. And that leaves you with a really important question to think about. Given the extreme length Meta went to, getting rid of Chinese investors, shutting down operations, What does that $2 billion price tag truly represent in today's AI ecosystem? Is that just the value of the technology? Or is it the technology plus the massive premium you have to pay for compliance and the immediate surgical removal of all geopolitical risk? Welcome to the deep dive. Today, we're examining the sources on the Plaud Note Pro. It's this AI-powered recorder that's become a quiet success story.
Yeah, especially with all the noise around other AI gadgets launching.
Exactly. So our mission is to really understand how this credit card-sized device managed to find its footing where some of the flashier competitors are, stumbling.
But I think it's so important to set the context here. We've seen this real flurry of new AI wearables. You've got
Yeah.
OMI, these pins that promise to be your always-on companion.
And rings, too. There's the Stream Ring coming.
Right. But Plaud took a completely different path. They seem to have targeted the professional user. They're prioritizing high-quality, discrete function over just being on all the time.
And the numbers we're seeing in the sources, they really prove that focus was a smart move. We're talking over 1 million units shipped.
Which is huge. But the more telling stat for me is the subscription conversion.
More than 50% of customers have converted to paid pro subscriptions. That just screams long-term utility, not just, a novelty.
It's not just fleeting curiosity. People are actually using it.
Okay, so let's unpack the design, because the physical device itself is a huge part of its success as a daily carry item.
Absolutely.
The Plaud Note Pro is all about discretion. I mean, it is ridiculously thin. We're looking at just 0.12 inches.
Which is what, like 3 credit cards stacked together?
Exactly. It's the thinnest AI recorder out there, and it weighs only so many grams. You just don't notice it.
And that size really dictates how you use it. You can slide it into your wallet.
Or, and this is clever, you can use the magnetic ring they provide to snap it onto the back of a MagSafe phone.
Right. It's just effortless to place it right where the sound is. But what really surprised the sources was that this tiny profile didn't mean they sacrificed on core functionality.
You mean its independence?
Exactly. A lot of these other wearables are basically just fancy microphones for your phone. The Note Pro has 64 gigabytes of its own memory right on board.
So it doesn't need a constant Bluetooth connection.
No, it's fully independent for recording and storage. That's essential for professional use. You can't risk a dropped connection.
Now, none of that matters if the recording quality isn't good. For a device this thin, the audio hardware is remarkably robust.
It's got 4 MEMS microphones.
And for anyone who doesn't know, MEMS mics are these tiny, high-quality silicon microphones. They're paired with a dedicated voice processor, too.
Yeah, for things like noise suppression and echo cancellation, it's supposed to have an effective range of over 16 feet.
And the reliability side of that is the battery, which is the real wow factor here.
Oh, absolutely.
It claims 30 hours of continuous recording and 60 days of standby. I saw one anecdote where a user, after 15 days of pretty heavy use interviews, conferences, still had 55% charge left.
Wow. That's the kind of thing that makes it a real tool, not just another gadget you have to charge every single night.
And the user interface seems just as intentional. Tiny screen for status, haptic feedback so you know it started. But the smartest feature has to be the highlight button.
I love this. The idea that you can press a button during the meeting.
Right, to mark a key moment, and then the AI summary automatically flags that section for you. It's brilliant.
And that customization extends to the software side. You get 300 minutes of free transcription a month, but you can also use different templates to guide the AI.
So you could ask for formal meeting minutes or just an action items list?
Exactly. Or detailed transcript if it's an interview. The AI shifts its focus based on what you need.
So what does this all mean for you listening? I think the takeaway here is that if your job involves a lot of in-person meetings, the $179 price tag is probably justified. The card design just gives you better microphone quality and, more versatile placement than some of those awkward pendant or pin-style wearables.
And that raises a really critical question, I think, for you to consider. Given how successful Plaud has been targeting professionals with this focused, discrete tool, what does that tell us about what the market actually prefers?
Right. Are we looking for specialized utility over general convenience?
Exactly. Is it about a dedicated, high-quality tool for a specific job? Or are people still searching for that one, always-on AI companion? That distinction might just define the entire future of this AI gadget market.
Welcome to the deep dive. For a long time, we've used large language models as, really smart advisors. They answer our questions, they write
They
drafts.
summarize things for us.
Exactly. But what happens when that advisor gains agency? Today, we're looking at this massive shift now that ChatGPT has direct app integrations. It's turning the chatbot from a passive advisor into a truly active assistant.
That is the critical pivot. So our mission here is to really distill how these integrations work, which ones offer the most value, and maybe most importantly, the big privacy questions you need to be asking.
Okay, let's unpack that. Getting started seems simple enough. You either type the app's name, like Expedia, find me a hotel, or you go into the settings menu.
Right, under apps and connectors.
Yeah.
But that simplicity hides what's really going on under the hood. This isn't just a fancy search. The AI can now read and write data directly into the partner's platform.
And that brings us right to the big caveat, doesn't it?
It does.
Mm-hmm.
Because if you connect, say, Spotify, you are granting the AI access to your entire listening history, your playlists, everything. You're giving it permission to act for you.
That's the part that needs a closer look. So if I connect Coursera and I use it to find a few Python courses, and then I get a little nervous and disconnect it from the settings, does ChatGPT just delete the data it just collected on my preferences, or does it just, stop collecting new data from that point on?
That is a great question. And the honest answer is it's a bit murky. In most cases, disconnecting stops future data collection for new actions.
Okay.
But the data that was already used, your search criteria, the courses it recommended, that's usually subject to the platform's broader data retention policies.
Yeah.
You have to assume you're permanently trading that piece of data for the convenience.
So once we've accepted that data hurdle, where does the real magic happen? What's the practical payoff for someone who's busy?
I'd start with workflow efficiency. Look at travel. With Booking.com or Expedia, you can give it really complex criteria like only 4-star hotels in the historic district with free breakfast.
Without clicking through a dozen filters.
Exactly. No filters. And the creative tools are fascinating too. I tried the Canva integration, and asking it for a 16.9 slide deck about our Q4 roadmap felt a little like cheating, to be honest. It just spits out that first draft.
That difficult first draft, yeah.
It accelerates your agency. You're not just asking for ideas anymore. You're asking Figma to actually generate a product roadmap with milestones and timelines.
It'll probably need some tweaks in the actual app, I assume.
Well, for sure. You'll need to polish it.
Yeah.
But it provides that working framework in seconds. And that same speed applies to, transactional things too.
Right. Let's move on to that shopping and food, where that kind of immediate speed really matters.
Absolutely.
Yeah.
The DoorDash integration for U.S. users is a total game changer if you hate making grocery lists. You can ask for a full meal plan, say 5 vegetarian dinners, and boom.
And it just adds everything to your cart.
Instantly. All the ingredients are right there in your cart, ready for checkout. Same idea with Target's integration. It can give you curated gift suggestions and create a shopping basket for drive-up or shipping.
And really quickly, there's also Spotify for creating mood playlists and Uber for checking ride options. But we have to remember, this whole rollout is currently just for users in the US and Canada.
For now, yes. But it's definitely growing. They've already confirmed partners for 2026. OpenTable, PayPal, and Walmart.
Wow, so we're moving into core financial and commercial services.
That's the clear direction. It's becoming more and more indispensable.
So the big takeaway here is pretty clear. The main benefit is just pure convenience, right? Doing everything in one conversational spot.
It is. But that brings us to the final thought, the big question for you. How do you balance that immense convenience, instantly filling a shopping cart, booking a room in seconds, with that fundamental trade-off? You're sharing your listening habits, your travel history, your purchase data with this newly empowered AI.
And when the barrier to action drops that low.
Exactly. When it's that easy, what new habits does that encourage? And maybe more importantly, are you comfortable with what the AI is learning about your life in the process?
Okay, let's dive in. We have a fascinating stack of sources today. The 10 most viewed publications of 2025 from Amazon Science.
Yeah.
And we're not just talking theory here. This is the research that's, actively building what's next in everything from frontier AI to deep system security.
And what's really striking is how the research clusters. You can see these clear, high-impact areas emerging. We're talking generative AI, formal verification, and some really advanced robotics.
It's the stuff that's shaping the infrastructure we all use.
Exactly. And it's shaping how you're going to interact with technology pretty soon.
So let's start with the new engines, the Nova family.
Yeah.
The one grabbing all the headlines is, of course, Amazon Nova Premier.
The big multimodal model.
Right, and everyone is talking about that 1 million token context window. I mean, that's not just a bigger number, that's a fundamental change.
It really is. Think about it. It means you can throw a massive code base or a huge financial report or even hours of video at it in one go.
No more chopping data up into little pieces.
Precisely. That whole complex chunking infrastructure just, it goes away. And while Premiere is for that heavy lifting, there's also Amazon Novasonic.
Which is all about the conversation itself, right? The actual interaction.
Yeah, the breakthrough there is that it unifies speech and text processing into one single architecture.
And what does that mean for us, for the user experience?
It just kills the latency. You know that awkward pause in most systems where it's clearly thinking? That's because it's translating speech to text, then processing, then translating back. Novasonic does it all at once. It makes the conversation feel, well, natural.
So the AI can interrupt, it can follow up. It's more of a co-pilot than a Q&A machine.
Exactly. But all that power, you need to be able to control it.
Which I guess is where the Nova 2 family comes in. They introduced this feature called extended thinking controls.
Right, so you get to decide. You can tell the model to be fast, or you can tell it to be more thorough and accurate, depending on what you need.
And that idea of control leads right into the safety side of things.
It has to. With models this powerful, security can't be an afterthought. The new Frontier Model Safety Framework is their answer to that.
So how does that work?
It's basically a three-step process.
Yeah.
First, you define what a critical capability is, what could cause harm. Then you evaluate for it, with humans in the loop. And if it crosses a threshold, you implement risk mitigations.
Okay, now this next part I found absolutely fascinating. Moving from safety frameworks to mathematical certainty and security.
The AWS paper.
Yes, they needed absolute proof for their cloud authorization, who can access what. And instead of just testing their old engine forever, they rewrote it.
In a language called Daphne, which is verification aware. I mean, this is so cool. It's like proving a theorem in math. You're not just showing the code might be correct through testing. You are proving it is correct with logic.
And the result was, what, a threefold performance boost?
Yeah. So they got perfect provable security and made it 3 times faster for customers. It's a huge win.
It's that same kind of rigor we saw in the paper on statistical power calculations revisited. Just making sure the results aren't just statistically sound, but actually mean something.
Right. Which, let's shift gears from the digital to the physical world, because the progress in robotics here is just astonishing.
Okay, Vulcan Pick. This system solves such a tricky physical problem. It can pick a specific item out of these densely packed fabric pods.
And fabric is a nightmare for robots. It's not rigid, it deforms, it's unpredictable.
But they cracked it. The proof is that it processed over 12,000 real customer orders in a live warehouse. This isn't a lab demo.
Not at all. And then you have the other side of that puzzle, the stow system, which is all about packing things in.
Right, and the innovation there is that it can handle deformable storage spaces.
Yeah, it can compress and shift things around to pack with human-level density and speed. We're talking over 500,000 stows completed. These systems are scaling and fast.
So when you zoom out, what this all really shows you is a very clear strategy. You build these incredibly powerful AI models, you lock down the core systems with mathematical proofs for security, and then you solve the messy physical world problems with advanced robotics. It's all connected.
It is, and that leaves you with a really important question to think about. We're seeing models like Nova. We're seeing dedicated AGI labs being set up. So how quickly do these scientific papers stop being academic and just become the default foundation for every single enterprise app you use?
That gap between the lab and the real world.
It seems to be closing faster than anyone, really predicted.
All right, so today we are doing a deep dive. We're looking at the biggest and most viewed research breakthroughs of 2025, pulling straight from sources like the Amazon Science blog. This isn't just a news roundup. This is really the shortcut you need to understand the scientific milestones that people were actually talking about last year. Our mission is to figure out how these advances are, fundamentally shifting the technology landscape.
Yeah, and if you kind of step back and look at the big picture, a couple of major themes really pop out. On one hand, you have this relentless push to make AI smarter, more general, and frankly, more autonomous. We see that with foundation models and agents. And then on the other side, there's this fundamental fight against the limits of hardware itself, which we saw play out in a big way with quantum computing. So today we're hitting those breakthroughs in foundation models, quantum error correction, and the architecture that really enables it all.
Okay, let's jump right in with AI then. Specifically, time series forecasting. We have to talk about Chronos 2. The first version already has this huge footprint, right? Something like 600 million downloads. But this new one, it's a massive leap. It goes from predicting just one thing at a time to predicting multiple things at once, and it even factors in outside data.
Right. And so what here, the real impact, is that it just solves this massive headache for anyone trying to coordinate resources. So before, if you were in cloud operations, you'd have to predict a CPU spike and then separately guess how that affects memory and then storage I/O. Chronos 2 lets you forecast all of that jointly. It captures those messy interactions.
And it does this with something called in-context learning, or ICL.
Exactly, which means you can just show the model a few examples of what you want right now, and it adapts on the fly. No more expensive, lengthy retraining every time something changes.
That adaptability is key. Okay, so let's shift from predicting time to predicting data structures. The foundation model theme continues with Mitra, which is all about tabular data. And this is where I found it gets really surprising. Mitra hit state-of-the-art performance, but it was trained entirely on synthetic data. Entirely synthetic. That feels a bit strange. I mean, aren't you running the risk of missing all the weird, messy stuff you only get from real-world data?
I know, it sounds a little backward, right? But that's actually the secret sauce. It's counterintuitive.
Yeah.
By pre-training on this huge volume of structurally diverse simulated data, they call them structural causal models, they actually cover a much wider range of possibilities than any single real-world data set ever could.
So it avoids overfitting to one specific messy data set.
Precisely. It makes the model incredibly robust when you finally give it a little bit of real data right at the moment you need a prediction.
Which is a perfect transition, actually. Speaking of breakthroughs, let's talk hardware, because the Ocelot quantum chip made some serious waves. But my question is this cat-quibbit thing really scalable? Or is it more of a cool lab trick?
Well, what's so fascinating here is just the sheer scale of the improvement. It's a practical leap. The Ocelot chip uses this technique with cat-quibbits to just crush errors, bit flip errors specifically.
Okay. And for you listening, the mechanism isn't as important as the result.
Right. The result is they got bit flip error times approaching 1 second. A whole second.
Wow.
Yeah. For perspective, conventional superconducting quibbits, you're often measuring their stability in milliseconds. So this is more than 1,000 times better. It's a huge difference.
And they did it with fewer qubits, too.
The critical point.
Yeah.
They got this super reliable setup with only 9 physical qubits, which just slashes the amount of hardware you need for a stable quantum computer.
And that kind of reliable hardware is exactly what you need for the complex real-time coordination that these autonomous AI agents will be doing. So if these agents are all talking, what language do they even use? I mean, with each other?
It's a great question. For this agentic web that's emerging, they have to talk to us in natural language. But agent to agent, that's way more efficient using embeddings.
Okay, so embeddings are like compressed vector summaries of data.
Exactly. Super compressed, meaning rich summaries. The problem, or the challenge, becomes context. If your travel agent AI is negotiating with a hotel's AI, the most efficient way is with these vectors. But how much of your personal data gets summarized in that vector?
So you're balancing efficiency with privacy. That's the next big hurdle.
That's the next frontier.
And we have to talk about the foundation for all of this, the actual infrastructure. Let's briefly touch on Amazon Aurora.
Yeah, Aurora's been around since 2015, and the big architectural idea was always decoupling the computation from the storage.
Right, which let it scale and heal itself.
But the critical milestone for 2025, the big news from May, is that all Aurora offerings are now serverless.
Which means what for the user, practically?
It means you just protect.
Yeah.
You don't worry about it anymore. No picking server types, no patching, no managing infrastructure. The baseline is now completely invisible and autonomous.
So let's just recap for a second. We've seen these incredibly specialized, context-aware foundation models for things like forecasting and data. We've seen quantum hardware take a massive leap in reliability. And the entire infrastructure it all runs on is becoming completely serverless.
And here's the thought to leave you with. You have models like Deep Fleet learning general traffic patterns to coordinate fleets of robots using billions of hours of data. You have other lightweight models like SOLM turning messy, unstructured data into clean, structured records all on their own. So what happens when you let all of these incredibly smart, specialized, generalizable AI agents loose on this brand new, totally serverless, infinitely scalable infrastructure? It's clear the technology is just rocketing towards full autonomy. The question you should really be mulling over is, how quickly will the legal frameworks catch up to govern this new world? Okay, so for today's deep dive, we are jumping into something pretty critical, a foundational challenge for some of the biggest language models being built today.
We're talking about the ones using that efficient mixture of experts architecture, the MoE models.
Exactly. And we're looking at a new solution from ByteDance Seed and Renmin University that seems to fix a really core disconnect in how they work.
That disconnect is what the researchers call decoupling. You see, in a MoE model, you have a central router that's supposed to send information or tokens to these little specialized experts.
Like a switchboard operator for data.
A perfect analogy. But the problem is, traditionally, the operator's decision isn't actually guaranteed to reflect what the expert is really good at.
So the router might think, okay, this looks like a math problem, and it sends it to the math expert. But that math expert is actually, say, terrible at calculus, and the router just had no idea.
Precisely. They are decoupled, and this is where the new solution comes in. It's this extremely elegant auxiliary fix called the expert router coupling loss, or ERC loss.
And its whole job is to force that router and that expert to be on the same page during training.
It forces them to be accountable to each other.
I understand the goal, but, I mean, MoE is all about being sparse and fast. A constant check like this sounds like it could be a massive computational bottleneck.
And that is the truly groundbreaking part of this paper. The mechanism is just so efficient. First, they basically interpret the router's internal settings, its parameters, as the ideal description for the kind of tokens an expert should be handling.
Sort of like its perfect customer profile?
Exactly. Then they create these slight variations of that profile, which they call proxy tokens, and they use those to test the experts.
So they're manufacturing the perfect little pop quiz for each specialist.
That's it. And this ERC loss then enforces two very strict but very lightweight checks. First is what they call expert specialization. Each expert has to activate highest for its own quiz, its own proxy token, compared to any other.
Okay, makes sense. And the second one?
The second is precise routing. This ensures the expert responds more strongly to its designated quiz than to any other expert's quiz.
So it completely locks in that specialization.
It locks it in and makes sure the router's settings actually mean something.
Now let's talk about that efficiency, because this is where previous attempts, completely crashed and burned.
Oh, absolutely. Methods like autonomy of experts or AoE, it's cost scaled with the number of tokens in your batch.
Which could be millions. Computationally ruinous.
A total non-starter for scaling. What's fascinating here is that the ERC loss operates only on n-squared activations, where n is just the number of experts.
And n is usually a small number, like 8 or 16.
Right, which means the computational cost is fixed. It doesn't care if you're processing 1 token or 10 million.
That is just massive. It means the overhead from this loss is basically nothing.
It's negligible. They reported it added only 0.2 to 0.8% during training.
And zero overhead during inference, which is when you, the user, are actually running the model.
And this efficiency led to just undeniable success at scale. We saw stable, substantial performance boosts on standard benchmarks like HelloSwag.
But the real test is always the huge models, isn't it?
That's the one. And the benefits held up when they scaled all the way to 15 billion parameter models on really tough benchmarks like MMLU. Those other methods like AoE literally failed to even train at that scale. The overhead was just too much.
So this is a genuinely lightweight fix that actually works in the wild. Yeah. But the paper also shows that the ERC loss gives us a powerful analytical tool, right, that could actually see the specialization.
They absolutely did. They used these TSNE projections to visualize the expert parameters. And you could literally see the experts go from being this messy, scattered cloud in a vanilla MoE to these tight, clearly separated clusters.
And they have a knob they can turn to, that hyperparameter, alpha.
Yes, alpha lets you explicitly control how specialized you want those experts to be.
And here's where it gets really interesting for anyone designing these models. They found that just cranking up that specialization to the max is actually a bad idea.
It's completely counterproductive, and that's the fundamental trade-off they uncovered. You need the coupling, you need specialization, but if you push it too far, the experts lose their ability to collaborate effectively.
And the model's overall performance starts to drop.
It does. There's a sweet spot.
So what does this all mean for you if you're the one building or optimizing these sparse models?
I mean, the ERC loss is one of those rare things in LLM research. It's a lightweight fix that delivers real, robust performance gains.
While also giving you these controllable tools to understand what's actually happening inside the model.
Exactly. And that brings us to the final provocative thought for you to chew on. The optimal degree of specialization isn't a fixed number. It's model dependent. They found an alpha of 1 was best for their smaller 3B models, but 0.5 worked better for their 15B models.
So the challenge for the future isn't just about forcing this coupling to happen.
No. The real challenge is finding that perfect empirical balance point between expert specialization and system-wide collaboration for your specific architecture.
That's the new calibration problem we all have to solve.